I almost always use a foreign key, and if my business logic doesn't require that I write code to traverse from the child to the parent, for example, I'll never have a book and want to know who wrote it without having to go back to the database, then I don't even bother with a navigation property. It does make things simpler when all I have to worry about is populating that foreign key property. In my case, it's an integer. So what's the benefit of eliminating the navigation if I'm not using it, besides the fact that I don't have an unused property hanging around? In the past, with Entity Framework and EF Core, if you had the navigation property in the dependent type, there were scenarios where not having that property populated would actually create problems. Most of those problems have gone away now as Entity Framework Core has gotten smarter. But when I'm designing my classes, rather than putting that reference property in there as my default pattern, in other words, if author has books, then book should have an author, I only add it if I know that I'm going to need it to fulfill my business rules of how I work with the books. I've also shown you that I don't need to have the author ID property in book either in order for EF Core to recognize the relationship. So why am I using it? Without the foreign key property, the only way I can add a new book to an author is through the author object, which means I will always have to have that author in memory in order to add a new book into the system. However, with a foreign key property available, I now also have the option of tying a book to the author just by setting the value of the author ID property. And quite often, that's all you have. Rather than saying, okay, now I've got the author ID property, I have to go and query for the author in order to add a new book to the author, you can just take that author ID property and create a new book and stuff it in there and save it, and it's fine. And in fact, I'm going to change the model to reflect this. It is so beneficial to have the foreign key property available that I'm going to add it into the book class. And there's another interesting benefit of having the foreign key property directly in the class. Remember when we looked at seeding data with the hasData method, but I only seeded the authors? In order to create seed data for dependent types, they must have a foreign key property. So now that the book has author ID, I can add some books back into the database. I'm using hasData again for books now below the code where I used it to add the authors. And just like the authors, I have to supply the key values, in other words, book ID, for these new books. But I also have to supply the foreign key values, and I'll use the author keys that I defined for the authors above. I'm going to perform one more modification to my model. When I initially created this demo back in the first module, I wanted you to see that EF Core would recognize ID as a key for author, but also book ID as a key for book because of the two different conventions. However, it doesn't make sense to have plain ID in one class and then the type name plus ID in the other class. And not defining and following some kind of naming convention in your classes, especially if you're working in a team, makes your code a little more difficult to read and to maintain. And for the keys, I do prefer the explicit convention of using the type plus ID. So I'm going to change the name of the author class's ID property to author ID. And I'm doing that using Visual Studio's rename feature, which I can access quickly with the F2 key, because it will also take care of renaming the same property in the hasData methods that I created earlier. So with these three changes, adding author ID to book, adding some more seed data, and changing the name of the key property in the author class, I'll go ahead and create a new migration, and I'll call it author ID change. And check out the migration file. It has a command to rename the author's ID column to author ID. That's because, again, by default, it's assuming I want the database name to match the property name. If I didn't want to muck with the database, I could have applied a mapping in the pub context to say that the author ID property of the author class maps to a column named ID. And then this renaming wouldn't have been necessary. But I like continuing that naming convention into my database as well. The migration file also has the logic to add the new seed data for books into the database. But what's not there is anything about the new author ID property in the book class. That's because the data model was already inferring the author ID foreign key, and the data model and database already know about it. But under the covers, EF Core can stop inferring that author ID, and it will just use the actual property. Now we'll go ahead and update the database using the migration. And looking at the database tables, the primary key of the authors table is now named author ID, and all of its existing data is intact. The book table schema hasn't changed, but note that the new books are in there. We won't be writing queries or saving data with the one-to-many relationship quite yet, so you'll see this change in action with queries and updates in an upcoming module. Let's return to that problem of an unconventionally named foreign key, and this will give you a little more insight into the power of overriding the conventional mappings with the Fluent API. If you're following along, note that I've unwound the experiments from the previous clip. That means I've uncommented the authors property in the book class, uncommented the books property in the author class, and I commented out the explicit mapping that I demonstrated in the pub context class. Without those changes, the results of the upcoming demos will not align with what I'm about to show you. I'm temporarily changing the name of the book's author ID property to author FK. And like before, I let Visual Studio help me with the rename, so author ID also got changed to author FK in the DB context. Looking at the data model diagram, notice what EF Core did. Because it didn't find a conventional foreign key property, it did what we've seen it do already, which is to infer that property. Here's the inferred author ID, which is noted as a foreign key, and author FK is just a random integer. And this is an example of what I love about EF Core's mapping capabilities. In this scenario, I named this property author FK because that's the way I wanted it to be. I don't want to have to change my business classes and my logic and my rules just to satisfy how EF Core is going to be getting that data in and out of the database. EF Core is just a mapper, and one of the many mappings it provides is the name of the foreign key. So I'm going to use that to override the convention. The foreign key mapping is an extension of the relationship that it's part of. So in the mapping, you have to start by telling the context which relationship in the model you're working with. And you'll use that same has many with one combo that we used earlier. In this case, the has many with one mapping is expressing exactly the same relationship that the convention already knows about. So it won't alter anything. It just gives you access to the foreign key mapping. And now on top of this, I can compose with the hasForeignKey method, and as its parameter, I'll use a lambda expression to reference the author FK property of the book entity. Now when I visualize the data model, there's no author ID property in book, and the author FK property is flagged as a foreign key property. I'm going to revert these changes, but I'll leave this mapping in the pub context file as a comment, so you can refer to it if you need. There's one last important concept I want to make sure you know about the one-to-many relationships, which is about requiring that every dependent has a principal or allowing that to be an optional relationship. By default, every dependent in the one-to-many relationship must have a principal. In other words, every book must have an author. The database will be modeled to have this constraint, and EF Core won't protect me from forgetting to provide an author or an author ID for the book. Let's take a look at that so that you won't be surprised if you get into that situation. Here, I'm creating a new book without an author ID or an author. After adding this book to the context, but before calling Save Changes, the author is null, and author ID by default, because it's an integer, is 0. It will be up to your business logic to ensure that the book knows about its author. Otherwise, you'll be pushing invalid data to the database, and it will throw an error. If your business logic follows that default, We will be looking more closely at providing the business logic to solve that problem in an upcoming module. But what if the publisher had a great idea for a book but didn't have an author to write it yet? If that was a business rule, then you probably do want to allow books to be saved without any knowledge of an author. And because that's different from EF Core's convention, you'll have to make some kind of change to your model. And there are a few ways you can do this. Because I do have the author ID property in the book class now, I could just mark that as a nullable int. Then, after migrating the database, the author ID foreign key column in the books table will be nullable, and an authorless book will be allowed. You can also use a mapping to specify that the author isn't required, and that will have the same effect in the database schema. And you'll do that with the has foreign key mapping that you just learned about. This time, I'm using has foreign key and passing in a lambda of the foreign key property that it already knows about. So I'm not telling it anything new there, but I can then compose on top of has foreign key with the is required method and pass in false. And that was easy to do because the author ID property exists in the book class. But what if I wasn't using the property? I can still achieve that using a string to reference that inferred author ID property that's in the data model. That's what this last bit of code is doing. Who imagined there was so much to learn about one-to-many relationships? But now you've got knowledge to handle a variety of scenarios and to avoid some common problems. There are a lot of ways you can set up your classes so that EF Core will recognize a one-to-many relationship between them, and even more if you take into account that you can override conventions with mappings for one-to-many. While they're not necessary for EF Core to recognize a one-to-many relationship, it's so helpful to have a foreign key property available in the dependent or child class. And you got a nice introduction to using mappings to fix some unconventional scenarios, such as when a foreign key property name doesn't follow convention, or enabling the parent or principal in a relationship to be optional. And throughout the module, you witness the power of being able to visualize how EF Core will interpret your model thanks to the EF Core Power Tools. This is a smart strategy rather than waiting for problems to pop up when persisting your data, especially when EF Core's interpretation of the data model might differ from how you thought it was going to work out. Before we continue using EF Core to interact with data, the next module will teach you how to capture logs of not just the SQL that EF Core is generating, but other activity in the EF Core APIs. Like the visualizer, having access to these logs can help you avoid problems as well as debug problems that are occurring in the EF Core pipeline. Here are some resources you might find useful for digging further into lessons of this one-to-many mappings module. I'm Julie Lerman, and thanks again for watching EF Core Fundamentals.